All right, in calculus at the moment we're studying how to find derivatives, rate of change functions if you will, for functions involving exponential behavior. So for example, we can see here that the variable t for time is an exponent on base e. This is an exponential function, and over here is some other stuff being done to the values. Nonetheless, what this function does is it'll tell you the height of an object, so it's projected vertically upwards. This will tell me the height of the object at any moment in time. All I need to know is how long was the object in the air. I put that here, here. That will tell me the height. The question is, how long is it going to take for the object to reach its maximum height, its highest height? Now you may recall we use calculus at this point because we're interested in when will the rate of change in the height of the object be 0. So essentially we're just basically trying to find the derivative, set the derivative equal to 0, and that will be where the maximum occurs. So let's see if we can do that. The first thing I did, as you'll see, is distributed the 220 here just to make my calculus a little easier. Then it's 1, 2, 3 unique terms. And to take the derivative, first the derivative of 220 is going to be 0, and then the derivative of an exponential function base e is itself, except for, let's not forget, right here, the derivative of the exponent itself. So the derivative of an exponential function is the whole thing times the derivative of just the exponent. And then, of course, we have the derivative of 20t, or negative 20t, which would be negative 20. That's my derivative. My objective, after I multiply the 0.2 negative times 220 negative is a positive 44. Now that I have the derivative then, I'm going to set the derivative equal to 0. In other words, my derivative, which is, oh, what happened there? I guess that must be a typo. This is supposed to be 44 e to the negative 0.2t minus 20 equals 0. So now we got it set, and there I had it right. We've got 44 e to the negative 0.2t equals 20, and I'm going to divide both sides here by 44 and then reduce. I should have reduced that to 5 over 11. I don't know what I was thinking, but nonetheless it's a smaller number. So after I divide both sides by 44, now I have an exponential expression. What I'm going to do here essentially, and in fact I'll even go back a little bit, is right here. What I'm actually doing is taking the natural log of both sides. The natural log of this equals the natural log of that. That's not very good notation, so we're going to get rid of it right now, but I want you to understand that's what I'm doing. I'm taking the natural log of both sides, and that should inform this outcome that negative 0.2t, which is the natural log of e to the negative 0.2t, is equal to the natural log of 10 over 22. Finally then, to find the value of x that makes the equation true, all I have to do is divide by negative 0.2, done, put that into a calculator, and I get 3.94 seconds. We should be clear what the question was, make sure we answered the question, and the question was, when will the particle reach its maximum height? So it just needed to know the time. I have the time. It's going to be 3.94 seconds. If I was interested in what the maximum height actually was, I could simply put that into the original equation and get the value needed. So that's all calculator work anyway. Since we're talking about calculators, we can enter the equation into Desmos as written, and then just touch the maximum or the top, and that will show us that 3.94 seconds we reach 41.15 meters. And of course, the Desmos is not always available like on tests, so we should also use our graphing calculators. Nonetheless, I actually, just to verify this is true, I typed in the natural log of 10 over 22 divided by negative 0.2, and I got the 3.94, which is consistent with what Desmos told me. So students, if you do your work like this on any test, and that is to say we have the analytical work where you do calculus, you solve the derivative when it's set equal to 0 to find a maximum or minimum, and then you do all that work and back it up with the graphing calculator, or Desmos, or both, then you're basically a complete whole math student as far as I'm concerned. So, thanks for listening.